Okay, so we're going to talk about triangles and relationships and facts and proofs, and we're going to hit parts of more than one of the modules I have listed, so I may need to kind of reorganize the syllabus a little bit here. And I'm going to not be able to make videos for the next few days, so I'm going to do as much of this as I can in a row, and you can just pause it as needed. So the first thing I'm doing here is something that would be better off doing if we had like little sticks of all different sizes. So you can try this. Basically, if you have a bunch of pencils that are all different sizes, or better, if you have sticks that are all different sizes, and you try to make triangles and see when you can. But the basic thing is, if I have one side of a triangle, then if the other two sides add up to less than that side, then if I attach them at the end like this, they can't meet. And if I keep trying to make them meet by pulling them down, they end up just stuck on there, so that you have a stick with two little legs folded over and you don't have a triangle. So because of that, if I have one side, the other two sides have to add up to more. Because if a line is the shortest distance between 2 points, then if I have to move away from the line and back again, that has to be a longer distance. So it has to add up to more. So you can look at 3 lengths and decide if you can make a triangle. So between these, the biggest one's 11, and 4 and 7 add up to 11. So if I laid those out, there's the 4, there's the 7, it just makes a line segment. And they do meet, but it doesn't make a triangle. 2, 9, and 5, 9 is the biggest, and 2 and 5 add up to less. So no, no. And the justification is just, so here, the sum of any two sides must exceed the third side. So no, because 4 plus 7 is equal to 11, 2 plus 5 is less than 9. On this one, 14 plus 15 is greater than 10. 14 plus 10 is greater than 15. 15 plus 10 is greater than 14, so this is yes. Now this one we need to work out. So the question is, when x is 5, this one's 15. When x is 5, this one is 9. When x is 5, this one is 25. 15 plus 9 is 24, is less than 25, so this one is no. So now we have that 3 sides of a triangle are 14, 6, and x, and we want to know the range of possible values. So remember, the rule applies to every selection, so 14 plus 6 must be greater than x. So we get x is greater than 20, that's the first statement. 14 plus x must be greater than 6, and 6 plus x must be greater than 14. So this one says that x is bigger than -8, which is not really helpful because it already had to be greater than 0 to be a side length. And this one says x is greater than 8. So really, as long as x is greater than 20, less than 20, this should have been a less than because I switched the order. X is less than 20 and bigger than 8, then we're good. So this is the lengths. Okay, so we want to look at this, and when you have a bigger angle, you're sort of opening up more, right? So the thing that we want to look at is to compare the longest side and the largest angle. The longest side is 4.3, the largest angle is 83. the shortest side and the smallest angle. The shortest side is 2.5, the smallest angle is 37. But if you think about this as kind of opening up, if I open up a wider angle, I get a longer side. If I were to open up this one, the side gets longer. So the bigger I make an angle, the bigger the side opposing it. So the interior angles and the sides opposite of them are the largest one's the largest one, the middle one's the middle one, the smallest one's the smallest one, and so forth. Okay, so the relationship of the interior angles, this is the same. So the larger the angle in a triangle, in a given triangle, the longer the side opposite. Now I could blow up this same triangle and have these all be miles instead of centimeters, and then obviously the one opposite 37 degrees would be bigger than the one in this triangle opposite 83 degrees. But in that new triangle, you still get the longest side opposite of 83 degrees, the shortest side opposite of 37, and the middle one opposite of the 60. Okay, we have a triangular deck, and they want to place benches in the largest corner. The largest corner is going to be the one opposite the longest side. The longest side is 27, 21, 18, 27. So she ought to place them here. In the triangle RST, angle R is 50 and angle S is 60. And we can glean from that right away that angle T is 70, because remember they all have to add up to 180. So 50 plus 60 is 110, so that leaves 70. So we want to list the sides of the triangle in order from the shortest to the largest. I'm not going to draw this to scale, I just want to point something out here. If the corners are R, S, and T, the side opposite R is the line segment ST. Opposite S is the line segment RT. Opposite T is the line segment RS. So we want them in order from shortest. The smallest angle is R, so ST will be the shortest side. The next one is S, so RT. And the next one is T, so RS. And it wouldn't matter if you put TS, TR, SR, like that either. We want to list the angles of the triangle cup in order from largest to smallest. So this is 7, and this is 25. And we haven't gotten yet to the Pythagorean theorem, but if I applied the Pythagorean theorem, I would find 49 plus this side, which probably honestly just got deleted here when I made the PowerPoint. 49 plus that side squared is 625, so that is 576, so that's 24, I believe. 16. Yeah, so from largest to smallest, the largest one will be opposite this 25, so U is the largest. The next one will be opposite the 24, so that's C. And the smallest one will be opposite 7, so that's P. So the sum of the interior angles of a triangle is 180. Okay, so this is called an exterior angle. So if you just continue on the line of a triangle beyond the triangle, the exterior angles are the ones that make up lines with the interior ones. So like this, or like this. But it makes a linear pair with one of the interior angles. So we want to identify an exterior angle. Well, the only one labeled is 4. And an interior angle adjacent to it. So that one's 1. That's the one that's adjacent to it. So the thing that I guess I didn't put in a slide anywhere is this. Because 1 plus the measure of angle 1 plus the measure of angle 4 equals 180, because they're a linear pair. And any exterior angle is a linear pair with 1 on the inside. Also, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, also 180. That means the measure of angle 4 and the sum of these measures are the same, because I took measure of angle 1 and added this to it and got 180, took the measure of angle 1 and added that and got 180. So these must be the same, namely 180 degrees minus the measure of angle 1. But at any rate, they're equal. Okay, so that means that I don't even have to solve for this inside angle here, because I know x is equal to the sum of these two, because x plus this one is 180 and the sum of these two plus this one is 180. So x equals 61 plus 39. Here I have these two are the same. This one's 48. So these two together, don't know how to kind of notate that, these two together add up to 132, because 48 plus 132 is 180. So each one of these is 66. Okay, so this one, well, this one's 90. So 90, 66, these two together add up to 156, leaving y to be 180 minus 156, which equals 24. And x is 180 minus 90 plus 48 is 138. So x equals 42. Okay, now on this one, 57 is also this one, because these are vertical angles. So this is 57. Because this one's 110, this one's 70, because you just subtract 110 plus this is 180. So 180 minus 110 equals 70, and that goes there. So y plus 10 equals these two added together. That's the theorem we just got. Y plus 10 equals 70 plus 57. So y plus 10 equals 127. Y equals 117. Okay, so this one, the first thing we know is that the 4x plus 2y plus 40 is 180. So 4x plus 2y is 140. And we can divide by 2 all the way through and get 2x plus y is 70. And then here we have that x plus 2x minus y equals 180. So that's 3x minus y equals 180. And you guys did substitution elimination. I'm going to put these two together and just add them. So I get 5x. The y's go away, 250. So x is 50. And here, 2x plus y was 70. So 100 plus y is 70. So y is negative 30. If one of these said y degrees, then we'd say there's no solution to this problem. But because when I plug in x and y, 4x plus 2y is 200 minus 60 is 140, so that's fine. And I put this in 100 plus 30 is 130, so that's fine. So we don't have any negative angles from this negative y. So these work. Okay, this one, 5x plus 3x plus 7x is 180. So that's 15, x is 180, x is 12. Okay, this one, we're using this alternate exterior angle, 5x plus 50 equals 7x plus 3x. So 5x plus 50 equals, 10x. So 50 equals 5x. And x is 10. Okay, so this one we have 10 equals minus x plus x squared minus 2x. 10 equals x squared minus 3x, and now we have a quadratic. X squared minus 3x plus 10, minus 10 equals 0. So two things that multiply together to give negative 10 and add together to give negative 3. So x minus 5, x plus 2. This one gives x equals 5, x equals negative 2. But whenever you have a squared, you may have introduced solutions that do not work. So we need to go look. I can't have negative 5, so this one can't be the answer. If this is negative 2, then negative x is 2, and x squared minus 2x is 4, plus 4 is 8. 2 plus 8 is 10, so this one does work. And of course it's not to scale, but it's almost never going to be to scale. And especially like if you're taking an SAT or an ACT, they will not be to scale. So you shouldn't judge anything based on kind of what you see. Okay, so this one, we've got 87 plus 33. So we have 120 right there, which means this is 60, which means this is 60 because they're vertical angles. So that's now 54 plus 60 is 114. So we have 66 over there to make the 180, which makes this 66, again because of vertical angles. Now 2x, don't think that this is an alternate exterior angle thing. This one's an exterior angle, this one is not. So this one is the same as this because of vertical angles again. So that means 90 plus 66 plus 2x equals 180. So that's 156 plus 2x is 180. 2x is 24 and x is 12. Okay, so 134 being here means that this one plus this one is 134. So you can do this a couple of ways. You can say this is 134, figure out what this one is, get this one in terms of x and relate them. But look, if this is x plus 2, then this one's x plus 2. And 134 is the sum of these. So 134 equals x plus 2. 134 is 2x plus 2. 132 is 2x, and x is 66. On this one, these two are the same. This one's 95, so 148 is this one plus this one. So 148 is 95 plus whatever this is. That's bad notation, but that's okay, because we're just solving. So if I subtract the 95, I get 53 is this thing. So this is 53. And x is this one plus this one. Well, that's 95, so this is 85. So x is 53 plus 85, or 138. Okay, so the ratio of the angles being 2 to 5 to 5 means they're 2 times something, and 5 times the same thing, and 5 times the same thing. So we have 2x plus 5x plus 5x all equals 180 because it's a triangle. So 12x equals 180, x equals 15. But the question is, find the measure of the smallest angle. The smallest angle was the 2x, because 2 is smaller than 5. So 30 degrees is the measure of the smallest one. In triangle CAT, C is 4 more than twice a number. C is 4 more than twice a number. Angle A is 7 less than 6 times the same number. A is 7 less than 6 times the same number. T is 103. So 103 plus angle C plus angle A equals 180. So subtracting 103 and substituting for these, over here I'll get 77. Over here I get 4 plus 2x plus 6x minus 7. So I get 8x minus 3 is 77. 8x is 80. So x is 10. So finding C and A, angle C is 4 plus 20. And angle A is 60 minus 7. So 24 and 53. Okay, these two side lengths are the same. So this is an isosceles triangle. In an isosceles triangle, you have two side lengths of the same measure, and remember that the measure of the angle has to be related, greatest to least, to the length of the side. So if the side lengths are the same, the angle opposite them are also the same. So 48 plus x is 180. So 2x is 132. Okay, so over here we have isosceles again, which means this is x. Because this is isosceles, and this is split too, that means that this is a right angle in both cases. Y is 90. Anytime you drop a vertical line, you end up perpendicular. If you've got the base flat at the bottom and you drop a perpendicular line, then you get 90-degree angles because they're perpendicular. And in the case where it's isosceles, if you split this exactly in half, then you've dropped a perpendicular line. So this is 90. So these two add up to 90. So x is 90 minus 32. So 58. Again, we have isosceles triangles. So this is 52. So this is 52. So x is 180 minus the sum of these, which is 104. So x is 76. Isosceles again. So this is E. So G is 112 because G is a linear pair with E and 112 is a linear pair with E. So that one is 112. E is 180 minus 112, so that's going to be 68. F is 180 minus 68 plus 68, because that's the other two angles in the triangle. That's 136. So we've got 44. Okay, so again we have isosceles. So we have E there as well, which means G and F are the same as each other. And E, well, 2E plus 62 is 180 because we have two E's there. So 2E is 118. So E is 59. And G, which is also F, is 180 minus E. So that's 121. Okay, so if this is 5x plus 2, this one is 5x plus 2. So x plus 5x plus 2 plus 5x plus 2 is 180. So we have 11x altogether plus 4 is 180. 11x is 176. So x is 16. Okay, so this video is basically in 3 parts and covers a lot more than just 3 subjects, but I guess I probably should break a moment and come back to it. So I guess I'll go ahead and upload this one and then do maybe the other 2 together. Maybe not.